Our final presenter is Peter Winslow, College of Biological Sciences, Department of Biochemistry, Molecular Biology, and Biophysics, PhD program.
Remember Jurassic Park? Well, just as scientists used DNA from a fossilized mosquito to resurrect the dinosaurs, we're attempting to breathe life into ancient molecules. Today, I'm taking you on a journey back in time to an era beyond the dinosaurs, to a time where biology as we know it is yet to exist. We're delving into the fascinating world of the origins of life and the birth of the first protein. Welcome to Primordial Park. Proteins are molecules that are made out of chains of chemicals called amino acids. They carry out all of the vital functions in biology. In order for there to be life, there must first be protein. Unfortunately, we can't just revive them like in Jurassic Park. There's no fossils, but in our lab, we have the next best thing. In nature, the birth of the first protein was a numbers game. Trillions of possible combinations of amino acids coming together to eventually form a protein, like the ultimate protein lottery. In our lab, we use a revolutionary technique called mRNA display to greatly increase our odds of winning this lottery. Think of it like high-speed dating for molecules. We chemically generate trillions of random 80 amino acid long proteins and screen them to find the perfect match for a specific function. In our case, binding to ATP, the universal energy currency of all life. While that's pretty amazing by itself, what allows us to say we're studying the first protein is that ours are built using only a subset of the modern amino acids. All of today's proteins use the same 20 amino acids, but we know that it was not always this way. In fact, it took biology hundreds of millions of years to gain access to them all. I imagine if I gave you 20 unique types of Lego, you could build a pretty fancy car. But what if you only had the 5 most simple types of Lego? That's what we wanted to find out. Sure enough, we found protein that could bind to ATP even when constructed out of only the 5 most simple amino acids. To paraphrase Dr. Ian Malcolm, it seems that life does indeed find a way. My goal is to determine how these proteins work. They're unlike anything that we've ever seen. The way that they bind to ATP is a complete mystery. But through the use of advanced techniques, we can get a glimpse at their 3-dimensional structure and use that to determine how they might grab onto ATP. Will we find eerily similar structures or fantastically new ones, unlike anything that has ever existed? Regardless of the outcome, the findings will tell us how proteins originated. This will shed light on how all life on Earth started, and maybe even tell us how life may start elsewhere. Thank you.